nature and definition of matter remains debated. Is there a single kind of matter, hyle, that everything is made of, or are there multiple kinds? Is matter a continuous substance capable of expressing multiple forms, hylomorphism, or a number of discrete, unchanging constituents, atomism? Does matter have intrinsic properties, substance theory, or lack them, prima materia? From the Enlightenment, French philosopher René Descartes, 1596 to 1650, originated the concept of matter. Descartes postulated matter to be abstract, mathematical substance that occupies space. Newton, 1664 to 1727, lists the universal qualities of matter as extension, hardness, impenetrability, mobility, and inertia. Joseph Priestley, 1733 to 1804, argued that the corporal properties transcend contact mechanics. Chemical properties require the capacity for attraction. German anthropologist Ludwig Feuerbach, 1804 to 1871, in his 1841 book, The Essence of Christianity, presented a humanist account of religion as the outward projection of man's inward nature. Feuerbach introduced anthropological materialism, a version of materialism that views materialist anthropology as the universal science. In physics, the double slit experiment demonstrates that light and matter can satisfy the seemingly incongruous classical definitions for both waves and particles. This ambiguity is considered evidence for the fundamentally probabilistic nature of quantum mechanics. This type of experiment was first performed by Thomas Young, 1773 to 1829, in 1802, as a demonstration of the wave behaviour of visible light. Subsequent experiments have shown that the same applies to atoms and molecules. Physics have found that observation of quantum phenomena by a detector or an instrument can change the measured results of this experiment. Despite the observer effect in the double split experiment being caused by the presence of an electronic detector, the experiment's results have been interpreted by some to suggest that a conscious mind can directly affect reality. However, the need for the observer to be conscious is not supported by scientific research. Bell, 1928 to 1990s theorem, is a term referring to the closely related results in physics, all of which determine that quantum mechanics is incompatible with local hidden variable theories, given some basic assumptions about the nature of measurement. Local here refers to the principle of locality, the idea that a particle can only be influenced by its immediate surroundings, and that interactions mediated by physical fields cannot propagate faster than the speed of light. The only way the hidden variables could explain the predictions of quantum physics is if they are non-local, that somehow the two particles are able to interact instantaneously, no matter how widely they ever become separated. Wheeler, 1911 to 2008, delayed choice experiments demonstrated that extracting which path information after a particle passes through the slits can seem to retroactively alter its previous behaviour at the slits. Erwin Schrödinger, 1887 to 1961, in his 1956 lecture, Mind and Matter, said that the world extended in space and time is but our representation. He sees that what we see as the physical world is simply a representation of a dualist consciousness. He believed that if the world is indeed created by our act of observation, there should be billions of such worlds, one for each of us, the many worlds theory. But how come your world and my world are the same? If something happens in my world, does it happen in your world too? What causes these worlds to synchronise with each other? There is obviously only one alternative, namely the unification of minds or consciousness. Their multiplicity is apparent. In truth, it is only one mind. That's a direct quote from Schrödinger. Thus he believes that we're living in a vast universal brain. Wolfgang Ernst Pauli in 1900 to 1958, with Carl Jung, 1887 to 1961, developed the theory that there is a psychophysically neutral reality and that mental and physical aspects are derivative of this reality. Pauli thought that experiments of quantum physics point to a deeper reality that might explain the mind-matter gap, and wrote, "We must postulate a cosmic order of nature beyond our control, to which both the outward material objects and inward images are subject." David Bohm, 1917 to 1992, went deep into fundamental philosophical questions about the core concept of physics. He defined matter as frozen light, meaning that light and life are the same essence in two different states of existence. All matter is a condensation of light into particles moving back and forth at average speeds which are less than the speed of light, he said. You could say that when we come to light, we're coming to the fundamental activity in which existence has its ground, or at least coming close to it. In addition to his scientific work, Bohm was deeply interested in exploring the nature of consciousness, with particular attention to the role of thought as it relates to attention, motivation and conflict in the individual and in society. Thus Bohm became interested in the work of Rupert Sheldrake, who was born in 1942, and Wilhelm Reich from 1897 to 1957. The universe's vast structure resembles our brain's neural networks, suggesting a conscious cosmos. This has been seen as a validation of the well-known phrase of Hermes Trismegistus, as above, so below. Although non-local connections and current scientific theory make this speculative. James Lovelock, 1919 to 2022, Gaia hypothesis sees the Earth as a self-regulating organism. This perspective emphasises Earth's interconnected ecosystem and humanity's role within it. The living universe views the cosmos as a living being undergoing evolutionary processes. Classical physics and chemistry, matter is a substance that has mass and takes up space by having volume. All everyday objects that can be touched are ultimately composed of atoms, which are made up of interacting subatomic particles. And in everyday as well as scientific usage, matter generally includes atoms and anything made up of them, and particles or combinations of particles that act as if they both have rest mass and volume. Relativity shows that matter and energy, including the spatial distributed energy of fields, are interchangeable. This enables the ontological view that energy is prima materia and that matter is one of its forms. In contrast, the standard model of particle physics uses quantum field theory to describe all interactions. In this view, it can be said that the fields are prima materia and the energy is the property of the field. Thus, materialist scientists believe that the universe is made up of matter, that we can understand the universe by describing the matter with which it is built. Hence the huge investment in projects like CERN, which attempts to find the fundamental particle, the smallest particle which makes up this matter. The standard model of particle physics is currently the best explanation for all physics, but despite decades of efforts, gravity cannot yet be accounted for at the quantum level. It is only described by classical physics. In the standard model of particle physics, matter is not a fundamental concept because the elementary constituents of atoms are quantum entities which do not have an inherent size or volume in the everyday sense of the word. But the standard model of science can only describe around 5% of the universe. The remainder is explained by dark energy and dark matter, of which very little is known. In standard cosmological calculations, matter means any constituent of the universe whose energy density scales with the inverse cube of the scale factor. Interestingly, in the standard model of astronomy, only 5% of the cosmos is known. Observational evidence of the early universe and the Big Bang theory require this matter to have energy and mass, but not be composed of ordinary barons, that's protons and neurons. The commonly accepted view is that most of this dark matter is non-byronic in nature. That is composed of particles yet to be observed by a laboratory. Maybe they are supersymmetric particles, which are not standard model particles, but relics formed at very high energies in the early phases of the universe and are still floating about. Noam Chomsky, who was born in 1928, suggests that since the concept of matter may be affected by new scientific discoveries, as has happened in the past, scientific materialists are being dogmatic in assuming the opposite. Applying this materialist logic to biology can be seen in the Human Genome Project, the CERN of biology, if you like. Despite massive effort and cost, decoding the human genome revealed almost nothing. Most important things are simply not contained within it. Only 22,300 sequences were discovered. It's about the same as other mammals, but much less than plants. Admittedly, not all sequences could be identified, but these would not explain the lack of information. The sequences seem to explain less than 10% of what are seen as hereditary diseases. This is known as the missing heritability problem. Even though cells can repair themselves, this ability was not revealed in the genome. The same is true of the brain, which can also repair itself, especially if the right brain is somewhat intact. Such observations mirror what appear to have been observed within the living universe hypothesis. Although the hypothesis conforms to Karl Popper's 1902 to 1944 view of science, that it is testable, and more experimentation is not only possible but desirable. This means that the laws of physics are evolving and not fixed, despite so much of the material science being based on this assumption. The Hoyle state is an excited spinless resonance state of carbon-12. It is produced via the triple alpha process, and this was predicted to exist by Fred Hoyle, 1915 to 2001, in 1954. And sorry, I mentioned Karl Popper died in 1944, it was 1994, much later. The existence of Hoyle's state has been confirmed experimentally, but its precise properties are still being investigated. Nevertheless, it's essential to the existence of life on Earth as we know it. One of the more bizarre and indeed interesting examples of applying materialism to the human environment comes from economics, or more precisely, econometrics. In 1949, New Zealand economist Bill Phillips, 1914 to 1975, developed a hydraulic machine to model the national economic processes of the United Kingdom, whilst Phillips was a student at the London School of Economics. Although designed as a teaching tool, it was discovered to be quite accurate, and thus an effective economic simulator. Of course, this gave rise to the computerized econometric models that I myself used to build and use. But is the matter versus consciousness argument really a left brain, right brain argument? The left hemisphere sees everything as made up of matter and be described from the bottom up, whereas the right hemisphere sees the universe as much more holistic. This is the reason why materialist science see others as somewhat deranged, because we simply don't think the same way. But rather than see matter as something physical that we can measure, maybe it's more an essential component of the philosophy of materialist science, which went hand in hand with the Enlightenment. Prior to the Enlightenment, consciousness was seen as much more important, as it continues to be in much of the world even today. But certainly the West's left brain thinking has dominated everything in our lives. And finally, I'll quote from William Blake, The Auguries of Innocence. To see the world in a grain of sand, and heaven in a wild flower, hold infinity in the palm of your hand, and eternity in an hour.